Good afternoon, everyone. Welcome to the session of urban planning subject. So, we were discussing about last time. We were discussing about water treatment, various water treatment process, including wastewater also, and most of the portion of wastewater is being covered in your subject water and wastewater analysis. So, we will concentrate on a topic which is not covered in that subject, even though we have seen the various method and the various process of water treatment in our previous lecture. And today we are going to learn about the stormwater system and design, its importance, and how it is one of the most important uh, parameter for urban planning. So basically, you might be knowing that what is a stormwater pipe pipes. So basically, the stormwater pipes are being designed to carry the whatever the surface runoff which is being generated in urban area due to the rainfall or snow melt. Okay, in India, basically, in most of the part of the India, the rainfall generally occurs. So most of the runoff will be generated due to the rainfall. But in a northern region, or you can say outer region, or country apart from India and kind of India, so where the significant part is of snow, then there will be a lot of generated due to the snow melt. Okay, but India, most of the region or most of the state and cities of India receive the heavy rainfall, and due to that heavy rainfall there will be a large amount of runoff generated, and that runoff has to be collected and safely discharged into the natural stream or any other, you can say, river. Okay, so we will start from basic. So so as I told you that what is a storm water. So stormwater is a part of rainfall, or as I told you, snow melt, which is either soaked into exposed soil, remains on the top of impervious surface like pavement or a rooftop. Okay, this is a theory portion. I will explain you in a simplest form uh, from image. Okay, see here this image. It's a urban scenario. In an urban scenario, what you will have? You will have roads, buildings, okay, some open spaces which can be either parks, okay, open plots where there will be a vegetation and no other commercial, or you can say homes being constructed, so it will be open space. So you can see here what you are seeing. It's basically a rainfall occurring over some places. There is a roads, rooftops means homes, open space like gardens, trees. All these things, all these things together forms urban hydrology. Okay, whenever there is a rainfall occurring over a, you know, the amount of runoff generated, basically depends upon a land use land cover characteristic of that region. In a land use land cover land use land land use land cover characteristic, what do you mean by land use land cover characteristic? Okay, so when you will see two things, first one urban region and another one which is a natural region, means a kind of region where there is a no urban activity. Okay, so you can consider agricultural land, You can consider forest where there is no urban activity or it is non-urbanized. You can consider as a non-urbanized agriculture and forest land. And on the other hand, you will have a urbanized land where you have impervious surface such as a road, buildings, okay, then footpaths, means number of things which are impervious. Now whenever you are having that kind of impervious surfaces, that surfaces will not let the water to penetrate into the ground. Okay, so what will happen? That water, on the other hand, if you will see agricultural land, okay, if you see on the other hand agricultural land or a forest, what you will see? See, this is another image. Okay, see here, you will see a clear idea what I am telling you. In a urban area, what you will see, you will have large amount of impervious land. Now that impervious land, whenever rainfall occurs over there in urban area, less amount of water will get infiltrated into the soil and large amount of rainfall water will stay over the land and move in the form of runoff. You can say surface runoff. On the other hand, in an agriculture field or you can say forest area, what you will have? You will have non or you can say a less impervious area. The whatever rainfall will occur over that kind of area, the large amount of water will get penetrated into the soil and less amount of surface runoff will be generated. So this is a basic difference, and this is the one of the reason why we are requiring stormwater in urban area, because due to the imperviousness created due to the urbanization, okay, we are constructing buildings, roads, footpaths, that all are the impervious surfaces which are not letting water to get infiltrated into the soil, so it will remain over the top of this impervious surface and move along the contours over the ground. Now another thing which is associated with this thing is that this surface runoff in an urban area will have certain kind of impurities. Okay, as we generally know that in urban area there are, in particularly in India, the roads are having various impurities in the form of plastic bags, you can say organic matter, we are throwing some vegetables everywhere like anything, or some, means there will be number of impurities which is remaining over a roads or you can say other impervious surfaces. Now whenever rainfall occurs, that all the impurities will flow with that surface runoff and gets into your storm drain, and that storm drain is being connected with your natural stream. See here in these photographs what you will see, whenever rainfall occurs, okay, so rainfall which is occurring over this kind of impervious surfaces will move, and while moving it will take all the surface impurities which is remaining over this kind of surfaces, means roads, buildings, footpaths, all these impurities will move along with your moving water. It will enter into your stormwater through this kind of opening which is known as a catch basin, okay, and that stormwater is being connected with your natural streams, and all these impurities will get directly into your water bodies, which can be either be stream, river, or anything. So this is the importance of stormwater, why we have to manage. And if you are not managing this stormwater, what will happen? If suppose that if there is a heavy rainfall is occurring, what will happen? and if we are not providing stormwater, what will happen? And if there is a sudden heavy rainfall occurring, that water, that surface runoff is not having escape route. Okay, so it will remain over the land and create like a flooding situation. Okay, if we are not providing stormwater, what will happen? And talking about that scenario, if we are not providing stormwater, what will happen? Whatever the rainfall occurring, the runoff generated due to that rainfall will stay over a land and create a flooding like a situation. Okay, even though we are providing sewer system, that sewer system have limited capacity. Okay, suppose that we are providing a combined system which is carrying a stormwater as well as sewer system, so it will have some limited capacity, so that the excess amount of water is always going to remain over your roads, and it will create like a flooding situation. So we have to design the stormwater by considering all these parameters, like what will be the rainfall, what will be the highest amount of rainfall which can occur over a city or a place. Okay, it is not like we are considering the average rainfall, we are considering a worst scenario which can occur in that region. Okay, the maximum rainfall which can occur in that region. So we have to design for a worst case scenario. Again, coming to our theory portion. So I hope you might have the clear idea from these two images what I am trying to say to you. So let's move to the theory portion again. So what is stormwater? It is a part of rainfall or snow melt, again, which either soak into exposed soil or moves over the land. Okay, so all these things occurring due to the urbanization, creating roads, footpaths and buildings. All these elements are impervious, and which is generating large amount of surface runoff in urban area. Okay, next thing, as I told you, that whatever impurities remaining over the land, over the roads, footpaths, that all impurities will move along your water, and that water will enter into your stormwater system and directly connected to the river. So all that impurities will move to your natural river and pollute it. And you know that we are taking, or you can say, the river is one of the main source of water distribution. We have studied various sources of water. There are two kind of sources: surface sources, subsurface sources. In surface sources there are various sources such as a river, small streams, lakes, ponds, reservoir. All these are surface sources. Okay, so all this water will move through your stormwater system, and that is being discharged into your natural stream. So it will pollute your natural stream, and from that natural stream we are taking a water for to supply after treating it to our public. So these all things are interconnected. Okay, so the reason you have now clear idea what is the reason behind the surface runoff, the imperviousness of the urban area. And all these things are its side effects, not side effect, but we can say uh, resultant effect of that urban runoff. So in order to deal with that, in order to sufficiently carry the storm water and to discharge or to dispose of into the natural stream, or directly into the sea. We have to design the stormwater system of a particular capacity of a particular capacity which will carry that surface runoff which will carry that surface runoff with certain degree of you can say uh, means we are designing in a such a way that even though if there is a worst case scenario, we will have sufficient little more amount of sufficient capacity, okay, to absorb that kind of runoff. See, you many of you have seen this kind of inlet chambers over the road. You know that it is being generally provided at the lowest elevation. You will see that the road you will see that the water which is coming from this side also, from this side also, and from this side also, all this water come to this one common point, and this water coming from each direction first will come into this catch basin, and after that catch basin it will go into your storm water, and all the storm water will be connected to a one main system, and that main system will discharge that storm water into your natural stream. You know, you will see this kind of stormwater system generally a rectangular shape in most of the cities. Okay, this is another example of that system. See, this is a sewage pipe, you can say sanitary pipe, and this is your stormwater pipe, which will only carry your surface runoff through urban area. Okay, so as I've told you again, so we after completion of a theory portion, we the thing which I would like to discuss with you is that how we what are the factors or not factors but how we are designing the stormwater system. So the one of the first important thing is before starting the designing or the first portion of the analysis is that the rainfall characteristic of that region. Okay. So as I've told you that we have to design for a worst scenario, so we have to determine that what is a or you can say what could be the rainfall characteristic, such as its intensity. Okay, how much amount of water not water but how much amount of rain can fall over that region in a given time period. Suppose that I am telling that for a Surat city or any other city, in a worst case scenario there could be a rain or a rainfall of a 10 centimeter or a 10 mm could occur in that 2 hour period or 1 hour period. So that is our worst case scenario. Okay, how much amount of rain could occur, how much means maximum amount of water or maximum amount of rainfall could occur over that region in a least period of time. Okay, so we have to determine that, and based upon that analysis we have to design our stormwater. So another thing which is important in the designing of a stormwater is that we have to also consider the topography of the region. So topography plays a one of the important role. Okay, as we know that ground surface is not even at all the places. It has certain amount of undulation, and undulation is also from vary from place to place. Uh, the ground contour will be different at every place. So based upon a ground contour, we have to see that these are the catchment which uh, the catchment will contribute this much amount of water to this particular storm drain. uh, you might be aware of the term catchment. So what is a catchment? The catchment is generally, you can say, if I have to give you the example, okay, if I have to give you the example of the catchment, okay, so let me give you one example of catchment. uh, Suppose that, see this figure, okay, see this figure, this storm line is there. Suppose that there is only one this line is going, don't consider this line, okay. Suppose that there is only this one pipeline is going of storm water, okay. So how much amount of water this storm line will carry, okay. So, and as I've told you that topography plays an important role, so we have to see the topography of that area also. Suppose that all these surrounding area all this surrounding area is having, you can say, downward gradient, is having downward gradient in this direction, in direction towards the sorry, in a direction towards the your storm drain, okay. So I'm talking about, suppose the slope is in this direction, slope is in this direction, slope is in this direction, okay. Then all the whatever the rainfall is occurring over this region, the runoff generated due to that rainfall will go into this stormwater, okay. Now suppose that portion only this portion is having slope in this direction, and this portion is having slope in another direction, then only this part of water will come into this stormwater, okay, because the topography is in that of that kind. So we have to see the topography also while designing the uh, stormwater system. Okay, so I think for today's lecture this will be enough, and we will discuss the further portion, and I will also trying to teach you the one of the I would also like to teach you the one of the uh, program, or you can say a tool, which is used for designing, or you can say modeling of a stormwater system. So I hope you all will download the SWMM tool, okay, SWMM, okay, SWMM tool, and so that we can do some hands-on practice on it, okay. Thank you.